In this video, we explore one of the biggest mysteries in physics: what creates time? A remarkable experiment has brought scientists one step closer to the answer. It all began with an extraordinary laboratory experiment. A physicist created a miniature universe.
Now we've moved to a universe in a box. We're trying to create a flat 2 + 1 dimensional spacetime. And then we're looking at excitations.
They observed something remarkable. Time appeared to emerge inside an isolated system with no external clock. These findings, published on June 11 in the renowned journal Physical Review Research, offer new insight into one of physics' oldest mysteries: what creates time? Some theories of quantum gravity suggest that the universe as a whole is static and time shouldn't exist at all. Nothing on the outside is affecting it. So how do we experience time? To investigate this puzzle, experimental physicist Giovanni Barontini of the University of Birmingham tested a radical idea that time is not a fundamental ingredient of reality, but emerges from the interactions between different parts of the universe itself. They cooled thousands of rubidium atoms to almost absolute zero until they merged into a single quantum object known as a Bose-Einstein condensate. They then split this tiny universe into two halves with a thin sheet of laser light. This created two regions. One was continuously monitored, the other was deliberately left unobserved and was called the dark region. What happened next was extraordinary. As atoms moved between the two halves of the miniature universe, entropy began to change. From those changes, time itself began to emerge. The greater the change in entropy, the faster time moved forward. The researchers call this idea entropic time. It is consistent with a long-standing view in physics that the flow of time is deeply connected to entropy. Many physicists believe this is why time seems to have only one direction. We remember the past, but not the future, because the universe has been evolving from a state of lower entropy toward higher entropy, and that naturally leads to one of the deepest questions in modern physics. Is entropy simply a way of measuring the passage of time, or could it actually be the reason time exists in the first place? That question has remained one of the biggest mysteries in modern physics. Barantini's experiment provides one of the first laboratory demonstrations showing how a sense of time can emerge from changes in entropy. For physicists searching for a quantum theory of gravity, that's a remarkable step forward.